Hi guys, this is the video for Chapter 7, Lesson 4. This is the last lesson of Chapter 7 we're going to do. After this, it will be the test. So make sure that you do some review. You can find a review test in your book and look over your old study guides and all that. But our next class period will be a test over this material. So in this lesson, what we're taking a look is at proportional parts and parallel lines. So previously we've been looking at proportional polygons and then proportional triangles. And so what we're looking at today is parallel lines that are seen in triangles creating proportional parts and parallel lines creating proportions in general. So what we notice is that if we have a triangle that's split into two parts by adding, basically adding a parallel line in between inside that triangle. So let's say that RS and XY here are parallel. What we're going to see is that these parts that are created by the parallel lines are proportional. So Rx compared to xt is proportional to sy over yt, and you can kind of see that here. Okay, and so what we see is that if they're proportional, then these two lines are going to be parallel. So you can actually reverse the logic and say, well, if I don't know whether they're parallel or not, knowing that these parts are proportional, then my lines have to be parallel. If they're not proportional, they're not going to be parallel. And so another thing that we see is that if you've got if the parallel line drawn inside is a mid-segment, that means that, so for example, that means that these two parts are going to be the same because a mid-segment is drawn by using the midpoint. So if this were 3, this would be 3, right? If this were 4, this would also be 4. So if there's a mid-segment, we know that those two parts are going to be the same. And you can also say that one part over the entire thing will be 1/2. And also because the proportions are big triangle compared to small triangle, it's double, or small triangle compared to big triangle is 1/2, then we also know that the parallel lines will follow that same proportion. So that means if this parallel line was 5, like this part XY was 5, then RS would be double, that would be 10, okay? So let's look at some examples here. First of all, let's just take a look at example 1. A few things I want to talk to you about. It's really easy to want to set up our proportions where it's not the parts divided by the parallel lines, it's the parts that are the same in between the parallel lines. So I just want to make sure that we're looking at AF would be over FB and AE would be over EC, or vice versa. So let's take a look at number 1. This is kind of like what we just talked about earlier. If these two are the same, then that means these two have to be the same, right? So X would be 7. Number 2, we're looking at the proportional parts. So I like to think of my parallel lines as like the fraction bar. So this would be 20 over X is proportional to 18 over 9. And so then you can cross multiply and figure that out. Or what you also see is that if these over each other is 1/2, then this has to also be 1/2, right? So I think X, I'm going to predict, would be 10. But let's just double check. 20 times 9 divide by 18, and it is 10, so X equals 10. So you can also look at the relationship of the parts. If what you see here is 2 over 1, then this 20 over X simplified should also be 2 over 1. Does that make sense? Okay, so here's an example where we're looking at the parallel lines. This tells us that these two parts are congruent and then these two parts are congruent, which means this smaller triangle is half of this big triangle. So if the proportions are 1/2, then this parallel line X would be half of 35. And so X would be 17.5. Okay, number 4, I'm gonna look at my parallel line as the fraction bar. So I'm gonna do 30 over 10 is equal to 24 over X. And looking at this, 30 over 10 simplifies to 3 over 1. That means 24 is 3 times as big as what's on the bottom. So I can kind of use that logic as well. And so I can think, what times 3 equals 24? I think 8, right? So you could cross multiply and find that, or you can use the logic of the proportions to help you find. But if I cross multiply, 24 times 10 is 240, divide by 30, that is 8. So X equals 8. Okay, over here, let's take a look. I'm given the entire length, but I don't have this part. So I think I'm gonna actually deduce that by subtracting. 33 minus 11 is 22. And then I'm just gonna set up my proportion. X over X plus 12 is equal to 11 over 22. And in this case, I have to cross multiply because I really don't know what X represents. So 11 times X plus 12, keeping that in parentheses, remember to distribute everything in. And then over here, I have 22x. So when I distribute, I have 11x times 1 plus 132. So 11 times 12 is equal to 22x. So I'm going to subtract 11 on both sides and then divide that by 11x. And so what I have left here is 11x equals 132. Divide both sides by 11. I think that's 12. So X equals 12. So when I work this out, I can even double check. X would be 12. And then this would be double that amount, which makes sense. This would be 24, right? 12 plus 12 is 24. So yeah, that logic works and my proportions are accurate. Okay, looking over here, X over X plus 10 equals 10 over 30. So cross multiply, 10x plus 100. Remember to distribute everything in, equals 30x. Okay, so subtract 10 on both sides. I have 20x over here, and 100 over here. Divide that by 20. 100 divided by 20 is 5. So let's just double check. This would be 5. And this would be 15, and you can think through 5 over 15 is 1/3, 10 over 30 is 1/3. So that you can kind of check the proportions to make sure that's accurate. So using that same logic, we are going to apply that to just parallel lines in general. So my trick, guys, is looking at the parallel lines as my fraction bar. So if you've got 3 parallel lines, the parts separated by the parallel lines are proportions over each other. So this is A over B is proportional to C over D. In this case, it would be W over X is proportional to U over V. So you're looking at those parallel lines and kind of you might have to turn your head sideways and look at that as your proportion. So another thing that we see is actually that if U over V is 1, meaning they're the same because that's the only time you have 1. So if this were 4 over 4, then that means W over X would also be 1. So if this were 5, then X would have to be 5 as well. So in this case, you don't actually have to work the problem out. You know that all those parts would be equal to each other. So let's use that idea here. These are my parallel lines. So I'm going to turn my head over and look at this as X plus 12 over 12. Is equal to 5x over 3x. And so this takes a little more algebraic solving where we need to distribute. So 12 times 5 is 60, 60x. In this case, I'm going to distribute my 3x into my x plus 12. Now, if I do this, guys, think about this. If I distribute this in, I'm going to have an x squared. So I think I'm going to try to be a little bit creative and solve by dividing everything by 3x. Because if I divide this by 3x, I can divide this by 3x. So when I do that, I get to bypass looking at a square root, which makes my life a little bit easier. So when creative and solve by dividing everything by 3x, because if I divide this by 3x, I can divide this by 3x. So when I do that, I get to bypass looking at a square root, which makes my life a little bit easier. So when I do x divided by 3x, the x goes away and I get 20, and then I have x plus 12. So I'm going to subtract 12 on both sides, x equals 8. That's my answer. Okay, looking over here, this tells me that all these parts are congruent, which means all these parts should also be congruent as well. So that means I can say 12 equals 2x minus 6. And I could also say that 12 equals x plus 3. And so solving x should be the same thing on both answers. So x equals 9 here. If I double check, plus, let's see, plus 6 on both sides, that'd be 18 equals 2x. X equals 9. Good. So that's my answer, x equals 9. Okay, so looking at my parallel lines as my fraction bar kind of thing, and I can set them over each other. Equals, ooh, I've got x and y. So let me double check my problem. Oh, this is nice. I've got these two parts being equivalent. So really what I could say is 2x plus 4 is equal to 3x minus 1. And then I could say 3y is equal to 2y plus 2. So subtract 2x on both sides, I get 1x. Add 1 on this side, that's 5. So x equals 5. Here, subtract 2y on both sides, that's 1y. Y equals 2. Easy. Looking over here, 5 over 8 equals to y over y plus 2. So cross multiply 5y plus 10 equals 8y. Subtract 5 on both sides, that's 2y, or 3y actually, 3y. And 10 divided by 3 is 3.3 repeating, 3 and 1/3, so 3.3 repeating. Okay, parallel lines are here, y over x equals 4 over x plus 4. And cross multiply 4x equals 3x plus 12, subtract 3 on both sides, x equals 12. That one was nice. Looking at my parallel lines, that's like my fraction bar, so y over y plus 3 equals 16 over 32. So this is 32y equals 16y plus, what's 16 times 3? 48. So I'm going to do 32 minus 16, which is 16, and then do 48 divided by 16, and that's 3. So y equals 3. And guys, I think that's it. So there you go.